Good day everyone, my name is Liza Ariston and I'm going to discuss the learning analytics using data-informed decision-making to improve teaching and learning. The topics that are about to discuss are define learning analytics, kinds of data used in learning analytics, kinds of analysis used in learning analytics. Fourth is kinds of pedagogical uses can learning analytics serve, and the key issues for the future of learning analytics. First of all, we will define the learning analytics. Learning analytics is the development and application of data science methods to the distinct characteristics, needs, and concerns of educational context and the data streams they generate for the purpose of better understanding and supporting learning processes and outcomes. There are four kinds of data used in learning analytics: source, quantity, and granularity of learning analytics data, kinds of learning analytics data, data, features, and proxy indicators, and the manufacturer data. In the source, quantity, and granularity of learning analytics data, there are two distinct characteristics of size. First, the overall quantity of data involved refers to collecting a much amount greater number of measurements on each person's action. The second one is the granularity of the individual data points. The measurements taken are more micro, such that taking the temperature of a room every 30 seconds instead of every 30 minutes. In other words, the computational analysis used in learning analytics generally require a greater amount of data than that used in traditional educational research. The kinds of learning analytics data: the activity data, artifact data, and association data. Activity data, traces of what students did. Artifact data, things that students created, and the association data can be made on the basis of similarity or interaction. Example of similarity is two students took the same course, and in the interaction, one student sent a message to another student. Data, features, and proxy indicators. More data does not necessarily mean more information. For an educational perspective, the justified linking of an observation to a conceptual entity is a critical piece of the logic chain for establishing the validity of learning analytics work. For example, should more time spent in an LMS be taken as an indicator of engagement or effort? The answer may depend on if the time relates to solving a problem. More time indicates the student exerted more effort, or reading discussion posts, more time indicates more engagement. However, from a data science perspective, the problem of selecting indicators focuses on how to transform the raw data into a set of features that best models the underlying phenomena. This process is referred to as feature engineering and includes feature construction, feature extraction, and feature selection. For example, it is difficult to help a student who is identified as being at risk for failing a course if there is no way to make sense of the factors that lead them to be placed into this category. There are also concerns with the use of features that might unintentionally reinforce traditional educational inequalities. For these reasons, theory can be a powerful tool to constrain and shape the possible degrees of freedom for constructing, extracting, and selecting features. The manufacturer data. Learning data are neither neutral nor natural. Not neutral since the data that are easiest to acquire may not be the most useful or important, and not natural as they are produced as students interact with design environments. Kinds of analysis used in learning analytics. There are 5 approaches, which are the prediction or supervised approaches, structured discovery or unsupervised approaches, temporal approaches, natural language processing approaches, visual approaches. The prediction or supervised approaches, these prediction models use a combination of attributes for a case, the predictor variables to predict the value of another attribute, the target. Kinds of use of prediction model. It forecasts an attribute for a case when it is not known, and explanatory. In this case, the focus is to better understand relationships between variables. Structure discovery or unsupervised approaches. It offers different ways to find patterns of similarity or relationships among cases or variables. Structure discovery methods, we can use it to identify regularities in variables and to identify commonalities and differences between cases. To identify regularities in variables, we have the correlation mining, which focuses on linear relationships between continuous variables. Association rule mining, it is used to generate if-then rules about the co-occurrence of categorical variables. And the factor analysis, a technique that finds groups of continuous variables whose values consistently align with each other and thus can be combined as a representation of some latent factor. To identify commonalities and differences between cases, we have the topic modeling, form of text mining that is used to represent the underlying structure across a corpus of documents. Clustering, commonly used to identify cases who consistently have similar values to each other across multiple variables. And the last one, the social network analysis, is a technique that looks for regularities not in the attributes of the case themselves but in the relationships between them. The temporal approaches, roughly divided into two. First, those which deal with time explicitly through examination of flow and fluctuation in features of the learning process over time. And second, those which deals with time implicitly through examination of sequences of events in the learning process. Similar to structure discovery, temporal approaches to data analysis also took to discover previously undefined patterns in the data. But in this case, the patterns relate to the sequence and flow of events over time. Natural language processing approaches, or NLP approaches, in learning analytics use computational techniques to assess various linguistic features of text. Textual data sources are the following: standalone student artifacts such as student essays or short answers, traces of dialogue among students and instructors, collection of instructional resources. NLP approaches are frequently used in combination with other analysis approaches already discussed, including prediction, structure discovery methods, and temporal analysis. NLP approaches is useful in learning analytics. It extracts linguistic features about words and their assemblages. Visual approaches. Much of the work in learning analytics using visualization is not actual visual analytics per se, but the visualization of the outputs of other analysis for communication with various stakeholders. Learning analytics dashboards, for example, often employ static graphical representation of analytic results designed to evoke particular responsive action. Examples of static visual learning analytics: human inspection of heat maps and moment-by-moment learning curves. Kinds of pedagogical uses can learning analytics serve? The tailoring educational experience, it is an initial class of pedagogical use of learning analytics, is for tailoring educational experiences to better meet the specific needs of one of more students. Tailoring of educational experiences for individuals or groups can occur through both adaptive and adaptable changes to a system that make it more appropriate for the learning of those involved. By the way, the adaptive is also be known as computer-driven and the adaptable means human-driven. Common analytic techniques that drive tailoring include prediction models, clustering to identify groups of students with similar profiles, and association rule mining. Informing student self-direction. Another pedagogical use of analytics is to support students in conscious attention to and improve of their own learning processes. This model of use draws heavily on psychological theories of experiential learning, self-reflection, and self-regulated learning, in which learning analytics provide feedback that students can use to adjust or experiment with changes in their learning behaviors. Supporting instructor planning and orchestration. For instructors, pedagogical uses of learning analytics can be used to support refinement of both the overarching learning design and the decisions they make to orchestrate classroom activity within it. Analytics can provide information that helps instructors identify struggling students, recognize groups that are collaborating more or less productively, and pinpoint prevalent points of difficulty for a class. In addition, another way in which analytics can help inform orchestration is by identifying types of students or student behaviors that occur repeatedly. Key issues for the future of learning analytics. The optimistic vision of learning analytics in higher education described above is far from inevitable. Others have countered such images of a rosy future with the potential for intentional or unintentional misuse of analytics, leading to a dystopian future of oversight and control. Key systematic and societal issues that will determine the fate of learning analytics include deliberate consideration of the policy needs required to govern the ethical dimensions of analytics use, and proactive planning for the required infrastructure. In conclusion, learning analytics is the development and application of data science methods to the distinct characteristics, needs, and concerns of educational contexts and the data streams they generate. The goal is to better understand and support learning processes and outcomes through both short cycles improvements to educational practice and long cycle improvements to the underlying knowledge base. This chapter has overviewed the distinct character of the data used in learning analytics, the kinds of analysis applied, and the pedagogical uses to which the analytics are put. Together, these characteristics highlight why learning analytics is seen as an especially promising technology to improve teaching and learning. To make this vision a reality, universities will need to be proactive in building up the requisite technical and policy infrastructure.